In the second and third parts of this video, we will measure valve spring pressure. We begin in part 2 by measuring the valve spring pressure at open valve, also known as the valve spring pressure at maximum valve lift. In part 3, we will measure the valve spring pressure at installed length. The first thing to check is whether the valve springs have the correct specifications for your type of engine. The VW Workshop Manual recommends measuring the spring pressure when the valve is fully open. We discussed this table in detail in part 1. You can read in this table the minimum weight and maximum weight, which the valve springs must meet, for each type of VW engine, and the length of the valve spring at open valve or maximum lift. We will therefore begin by measuring the open valve pressure of all the valve springs we disassembled in the engine overhaul video 16. For this we will use a simple valve pressure gauge, a type of manometer, which you can operate using a vise. This type of gauge is sufficient for measuring the valve spring pressure of a standard VW engine. A factory Type 1 engine will have a valve spring pressure between 5 and 10 kilograms per square centimeter. You will have already noticed that VW displays values in kilograms, while our valve spring pressure gauge indicates kilograms per square centimeter. But we'll come back to that in a moment. We'll start with the valve springs on our AB 1300 engine. Use jaws with a soft finish on your vise to protect the valve spring and pressure gauge. Place the valve spring with valve pressure gauge between the vise. Make sure the valve spring and gauge are centered. The direction of the valve spring has no importance for spring pressure measurement. The open valve length of the valve spring for our AB 1300 engine is 3.10 centimeters, as listed in the table. Tighten the vise until the valve spring is compressed and is still 3.10 centimeters long. We use a caliper set at 3.10 centimeters. When the valve spring has reached its open valve length, you can read the spring pressure on the scale of the gauge. Here you see how we measure with a caliper the length of the depressed valve spring. For this type of cylinder head, the open valve length is 3.10 centimeters. We measure a pressure of 8.8 kilograms per square centimeter for the valve spring of the exhaust valve of cylinder 1. Hold the valve spring and pressure gauge firmly while unscrewing the vise. We do the same for the valve spring of the intake valve. We measure a pressure of 8.0 kilograms per square centimeter at an open valve length of 3.10 centimeters. We perform the measurements for the other 6 valve springs and summarize the results in one table. The pressures for both cylinder heads fluctuate between 7.8 and 8.8 kilograms per square centimeter. VW indicates that the original AB 1300 valve springs should exert a counterweight of at least 53 kilograms and a maximum of 61 kilograms at maximum valve lift. VW gives the weight in kilograms, not the pressure in kilograms per square centimeter. To know the pressure in kilograms per square centimeter, you need to know the area of the valve spring on which the pressure is applied. Therefore, we need the diameter of the valve spring. The valve spring of our AB 1300 engine has a diameter of about 3.09 centimeters. Measure the diameter of all valve springs to make sure they are all of the same type. You can also measure the diameter of the windings. They should all be the same thickness. With the diameter of the valve spring, you can calculate its compression area, indicated by the capital letter A, as follows. The area is equal to the diameter, times the diameter, times pi, and this is all divided by 4. We arrive at a surface area of 7.50 square centimeters. We can now convert the value we read on our valve pressure gauge into a weight to compare with VW's table. We multiply the measured pressure by the area of the valve spring to find the weight in kilograms. We supplement the measured data with the calculated values in kilograms. The first valve spring is 66 kilograms. Ideally, start looking for a valve spring that is within specifications. The slightly higher pressure at fully open valve is good to prevent float, but it causes accelerated wear on engine components. The other 7 valve springs are perfectly within VW specifications, namely between 53 kilograms and 61 kilograms. In part 3, we will measure the valve spring pressure at installed length. We then measure the valve springs of the first 1600 cylinder head, which we disassembled in part 2 of video 16. We measure the diameter of all the valve springs, as well as the diameter of the windings. The diameter of the valve springs is about 3.11 centimeters. This corresponds to a contact area of 7.60 square centimeters, calculated using the formula we showed earlier in this video. The diameter of the windings is 4 millimeters, except for the inlet valve spring of cylinder 2, which is 4.2 millimeters. This tells us that at least one valve spring is stronger than the other 3. It should not be. When we put the valve springs of this cylinder head side by side, we see that the valve springs of cylinder 1 are identical, and both are of the progressive type, as they should be. Cylinder 2 has a thicker progressive valve spring and a linear valve spring. The linear valve spring, at first glance, does not belong in a 1600 cylinder head. To be clear, in one engine, all valve springs should be of the same type. We will get more clarity after measuring the valve spring pressure. We now measure the force of all valve springs of this 1600 cylinder head. We measure 7.5 kilograms per square centimeter at an open valve length of 3.10 centimeters for the first valve spring. 6.8 kilograms per square centimeter for the second valve spring. 10 kilograms per square centimeter for the third valve spring. And finally, 6 kilograms per square centimeter for the fourth valve spring. For this type of engine, the valve springs must be able to exert at least 53 kilograms of counterweight and a maximum of 61 kilograms. Only the exhaust valve spring of cylinder 1 is within specifications. The inlet valve spring of cylinder 1 is just below the allowable minimum value. The one of the inlet of cylinder 2, with its 76 kilograms, is basically too strong for this type of engine. This of the exhaust of cylinder 2 is much too weak for this engine, and it is not of the progressive type, but linear. Because of the big differences between the 4 valve springs, we will be best to look for new valve springs for this cylinder head with the right specifications. Now it is the turn of the second 1600 cylinder head. We disassembled its valve springs in part 2 of video 16. That's the cylinder head from which one valve was jammed. All the valve springs were very corroded. We measure the diameter and the thickness of the windings. The diameter of all the valve springs is about 3.12 centimeters. The thickness of the windings is 4 millimeters. We calculate the pressure area and come up with 7.65 square centimeters. What we do notice is that they are all linear valve springs. They are also longer than standard springs. A standard valve spring for a 1600 engine, like the one on the left in the picture, is about 5.20 centimeters long. This one on the right is 5.97 centimeters. Upon examination, it will turn out that these are reinforced valve springs, used on a high valve lift engine. Since we don't know the specifications of that engine, we'll use the standard data. So we will measure the pressure of each valve spring at a standard open valve length of 3.10 centimeters. In practice, the valve pressure at open valve will be greater than what we will measure here, because with a high lift setup, the valve spring is pressed 1 to 2 millimeters deeper. These are the results, with the conversion to counterweight, as stated in the VW manuals. Clearly, these are stronger valve springs than standard, with greater length at rest, so, not usable for a standard Type 1 engine. We measured the valve spring pressure at open valve length for all the cylinder heads we disassembled in video 16. The next measurement we will make is to measure the valve spring pressure at installed length. We will do that in part 3 of this video. More information about all the parts and tools used in this video series can be found as comments under each video on our YouTube channel. See you soon.